Let us discuss Ingen-Hausz experiment. Ingen-Hausz experiment. Heat flow rates from solids can be compared by having an arrangement consisting essentially of a box to which rods of different materials are attached. And this arrangement is called as Ingen-Hausz experiment. The rods are of the same length and area of cross section, so they are of same size and same shape and same diameter. Their outer surfaces are electroplated with the same material and are equally polished. This is to ensure that for each rod, the surface heat transfer will be the same. The procedure would involve coating the rods with wax and filling the box with the same. Heat flow from the box along the rod would melt the wax for a distance which would depend upon the rod material. So let us understand what this Ingen-Hausz experiment is all about. So there is a box containing some heat source, and to this box rods of different same length and same diameters are attached. For example, I am representing here only three rods. More and more number of rods can be attached to one side of this box. Let's say thermal conductivity of the material of the rod 1 is K1, K2 and K3 respectively. Now let's say because of the heat, all these three rods are electroplated with wax. So depending upon their thermal conductivity, heat will be transferred from this end to this end of the rod, and depending upon their thermal conductivity, the wax will be melted. And let's say the length is L1, L2 and L3 respectively. So in order to analyze how this thermal conductivity of the different rods depends or related with the length L1, L2 and L3 respectively, let us consider theta O equal to excess of temperature of the hot bath about ambient temperature, and theta M excess of temperature of melting point of wax above the ambient temperature. So this box containing hot bath. Similarly, let us consider L1, L2 and L3 length up to which wax melts. In order to find out the relationship between thermal conductivity K and length of wax melted, let us consider all these three different rods of pin of infinite length. So basically what we are going to do, we are using heat transfer from extended surfaces. Basically, we are using the theory of heat transfer from extended surfaces to find out the thermal conductivity of particular material. So if all the three rods are considered as fin of infinite length, I can find out temperature distribution for rod 1 as eta m is equal to eta o e to power minus m1 L1. This temperature distribution we have already found out. For rod 2, considering it as a rod of infinite length, eta m will be eta o e to power minus m2 L2. And for rod 3, theta m is equal to theta o e to power minus m3 L3. The temperature distribution is same because both the rod's ends are exposed to the same condition. Now from here, as you can see, so it is quite obvious if you will see all these three equations, e to power minus m1 L1 will be equal to e to power minus m2 L2 is equal to e to power minus m3 L3. Or I can also write it as m1 L1 is equal to m2 L2 is equal to m3 L3, where m is a constant and it is given as hp over KAC, where H is the convective heat transfer coefficient of the surrounding fluid, P is the perimeter of the rod, K is its thermal conductivity, and AC is cross-sectional area. So writing the equation of M1 for rod 1, it will be H into P over K1 into AC. Because what is happening? All these parameters are same, H, P and AC for rod 1, 2 and 3 respectively. Similarly, M2 will be HP over K2 AC square root into L2 is equal to HP over KAC into L3. After simplification, it will give me L1 over square root of K1 is equal to L2 over square root of K2 is equal to L3 over square root of K3. Further simplification will give me K1 is equal to L1 square is equal to K2 is equal to L2 square is equal to K3 is equal to L3 is equal L3 square, and this will be constant. So from the analysis of this Ingen-Hausz experiment, what I can concluded, the thermal conductivity of the rod material is directly proportional to the square of the length of the wax melted on the rod. So Ingen-Hausz experiment basically is using heat transfer through extended surfaces theory to find out the relationship between thermal conductivity and length of the wax melted. This analogy is used in many cases to find out the dependence of thermal conductivity or relation of thermal conductivity of different materials used as fluids.